Getting into the digital reality, you give a metaphor of World of Warcraft, and the one I love the most is the hard drives, the ones and zeros. Could you talk about the way that digital reality works in relation to the tree falling in the woods?
Yeah, the tree falling in the woods is a kind of a cute little metaphor that I use in my workshops to explain the nature of a virtual reality, a reality based on probability and statistics. Okay, is what we have. So first, we have to understand the basic fundamentals. We are consciousness. Okay, we're not a physical body. We are consciousness. Consciousness is not physical. Consciousness is an information field, a digital information field. Okay, this digital information field is producing our universe, our planet, and the whole universe as a simulation. And this idea is catching on in science. There's more and more scientists who are realizing that this answers the mail. It answers more of the questions of physics than the old idea, which is we're living in objective reality. It's basically what quantum mechanics has been telling us. So to begin with, we're consciousness. We're getting a data stream. We interpret this data stream as our physical reality. We live in a virtual, computed, if you will, simulated reality. All right, now, how does that work? Well, I use this little idea about the tree in the woods, and everybody's heard this little phrase that if a tree falls and there's nobody there to hear it, doesn't make a sound. Okay, that's a common thing. I'm sure all your listeners have heard that. Well, the answer to that is that there really is no tree, there is no woods. All of that exists only as data. And here's how it works. When a person walks into a woods, and say this is a woods that nobody's walked into before, so we're just making up a little thought experiment here. So a person walks into the woods, and he looks around, and he sees a dead tree that's standing up. Okay, now why does he see that dead tree that's standing up? He sees that, and the rest of the woods, he sees it because that is probable what he would see. Okay, now before there was just a woods there. You kind of saw that there was a woods, and you could only see maybe 10 feet into the woods. It's because it was so thick. So that's all you knew about it. So when you walk into something that nobody knows, then you get what is probable. Okay, there's all the possibilities. Now there's because you can see the trees from the outside, you can see the woods, then you know there's more trees in there, so that limits the possibilities. The fact that it's a deciduous woods means that when you go in, you're not going to see bunches of pine trees, that sort of thing. So the things that are possible within the limitations of two things. One, the possibilities have to be consistent with history. So you're not going to walk in and find, like I say, a bunch of pine trees and a lake full of sailboats. That's not going to be in that woods. That doesn't match with what we know, what history says, that this is an uncharted or a woods that nobody's walked into before. So you're not going to see any of those things. So it's not just random what you see. It has to be consistent with the history. Up to that point, we have to have consistency within our reality frame. Secondly, it has to be consistent with the rule set. The rule set is basically science. It's all the rules about how our reality works. So it can't violate any of the rule sets. Somebody walks into this woods, they have to see something that meets historical consistency and within the rule set. But within those two constraints, there are literally thousands of things that are still possible. Well, when he walks into that woods and takes a look, basically he reaches up into he doesn't, but the system goes into the ensemble of things that are possible into that statistical distribution and randomly pulls one out. Okay, and what it happened to pull out for this man to see was a dead tree standing up, wobbling a little, but still standing. Okay, so that's why he sees what he sees. That's how a statistical probabilistic reality works. Now, let's say he turns around and he walks out of the woods and 2 minutes later, he runs back in, and what will he see? Well, he will see that dead tree still be there, because now that's part of the historical record, right? He saw that tree. Maybe he took a picture of it. And that once something comes into the reality frame, it stays in the reality frame. It becomes part of the historical record, therefore it needs consistency. Okay, but now let's say that he walked into the woods for the first time. Then he comes out of the woods, and just as he walks out of the woods, he runs into a hungry grizzly bear and gets eaten by the bear. Okay, now that information is gone, and if he took a picture, the camera gets smashed and eaten by the bear as well. Okay, so it's gone too. So let's say that happens. Now, if somebody else walked into that woods, say an hour later, bear's gone, body's gone, somebody else walks into the woods, will they see that dead tree? Not necessarily. You see, that information is no longer in our reality frame. It's gone. There's no reason to pick that particular thing. So it goes back up into that probability distribution, picks another random, and that's what they will see. Okay, now if they don't get eaten by a bear, then that consistency will have to stay there, particularly if they take a picture, make a movie or whatever, then that becomes the way it is. It eventually, what is in our reality frame is known, becomes part of our history, and then it must persist. All right, so these are just a couple of things. Now let's say that the first guy, we'll go back to the beginning now. The first guy walks into the woods, he sees the dead tree. He walks out of the woods, he comes back 5 years later and walks into the woods, and he no longer sees this dead tree standing up, but he sees a dead tree lying on the ground. So did the dead tree fall over in that 5 years? No, not actually. He gets an image of data, remember this is a virtual reality, of the dead tree standing up. 5 years later, he gets an image of, in his data stream, of the tree lying down. Why? Because in 5 years, it's probable that wind and weather and how dead the tree was, that the tree would have fallen over. So now when he walks in, there's a different set of probabilities, that not like the first set, because now we have the condition that the dead tree was there. In the second set, it's probable that that dead tree has fallen over. So that's what he sees. So the tree really didn't have to fall. He gets a picture of it when it's standing, a picture of it when it's lying on the ground, and there are no states in between. The only reason you assume there are states in between, that it had to fall to get from standing to the ground, is because you believe in an objective reality. And in an objective reality, indeed, it would have to fall. But in a statistical and probabilistic reality, that doesn't have to happen. So it is standing, then it is falling, because it was probable in each case that that's the way it would be. So that's just a little kind of example to give you an idea of how a virtual reality works. And when I give this in the workshops, I tie it into the double slit experiment. See, the double slit experiment works in a similar way. You have a particle, one particle gets tossed at two slits, and it forms a diffraction pattern. That means that it will produce a series of bumps of light on the screen. Let's say this particle is a photon. And it doesn't matter. Particle could be an electron or a hydrogen atom or any such thing, but it will produce this diffraction pattern. And it does that because it's only a potential particle. It's only a probable particle, just like it was a probable dead tree when the guy first walked into the woods. And that probability of that probable virtual particle goes through both slits, interferes with itself, and produces a diffraction pattern. Now, if you put detectors at each slit, so you can tell which slit does the particle go through, you do not get a diffraction pattern. You'll get a spot of light right behind the slit that the particle goes through. Now, one particle doesn't create a diffraction pattern. I should say that we're talking about firing lots of particles at these slits, but only one at a time. So they will either pile up in a pattern of a diffraction pattern, or they will pile up just behind one slit. Behind one slit, if you actually look and see what slit it goes through. So you see it's the same thing. Once you detect a particle at a slit, then that particle now, for historical consistency, has to remain a particle. which means it travels in a straight line unless interacted by other forces. So it hits the spot right behind the slit. If you don't see that there's a particle there, then it's still probability. It's probability as it passes through the slits, and therefore it then distributes itself in a diffraction pattern that has no light behind either of the slits. If it's set up right, that's a null spot where there is no light. So the two work the same way. Basically, you have reality that is probabilistic and statistical. It doesn't come into this reality frame till somebody needs the data, or somebody looks, is sometimes how it's said, but somebody collects the data by going into the woods or by looking at the screen behind the slits or by measuring the particles. Somebody collects the data, and when it does, then in quantum mechanics they say that the probability wave collapses to a physical particle, and after that it has to act like a physical particle. So we see that the quantum mechanical double slit experiment and my tree in the woods all work exactly the same way. So reality is reality. The concepts of quantum mechanics, being particles being only probability, is not limited just to tiny particles. All of reality works in the same way. There isn't a science for little things and then a different science for big things. That only appears that way if you believe in objective reality.